Okay, great. Fantastic. I can see that all systems are check and we are a go. Hello and welcome. My name is Amritash. I'm based out of Bangalore. I want to admit right up front that I'm not an embedded engineer. I'm not a systems coder, not a hardware engineer. So I'm going to make a lot of mistakes and hopefully everyone else can correct me. Um, but I do work with embedded engineers on the business side of things. So you can say business adjacent to them. Let me start by introducing our panelists today. I'll go in order of who's first done their systems coded, how many years back that goes to. So, Sai, you're first. We have Sai Ranjan. Sai started his career in Philips, then Cisco, then Toshiba, then Bosch. So, hardcore engineer. And after these four companies that he worked for, he turned an entrepreneur. And this is when we are meeting him today. He's at his fourth company. He's the co-founder and CEO of a company called H2 Loop, which builds AI coding tools for hardware engineers. H2 Loop is funded by specialist deep tech investors. Called, Speciale is one of your funders. Sai, that's amazing, and 314 Capital. We will learn a little bit about H2 Loop and Hydron, which are their products during the call. Welcome, Sai. Any opening thoughts?
Thanks, Samruth. Hi all, I'm Sai. I'm the co-founder and CEO of H2Loop.ai. H2Loop stands for Hardware and Human in the Loop. As Samruth mentioned, we are a deep tech startup building coding models specifically for hardware-first industries. We have a product called as Hydron, which you guys can go and try it out, where it can help you in expediting your lower level system software development. If you want to develop any kind of a firmware, device driver, or any kind of embedded software, you can use this tool. The key part about this tool is it understand your hardware in a much better way, and based on that, it generate code. We don't believe in writing a lot of code. Our thesis is always writing very accurate code, because in this industry, like purely at a system software side, it's not about writing huge amount of code, because if something goes wrong, the results will be catastrophic, right? So this software goes inside into most of the edge devices, right from your smartwatches to your car, rockets, as well as your networking equipments and all those things. So it has to be very tricky when you are writing this code. And right now we are advancing in a fastest way to write a lot of code through AI. But again, just reiterating, we write very trustworthy, compliant, traceable, and auditable code. Yeah.
Nice, great introduction. Thank you, Sai. We will talk about your personal journey through coding over the years also. I want to welcome Shashwat. Shashwat is the co-founder and CEO at MindGrow, also an embedded engineer to start with. I forget where he started his career, but now he is the CEO of one of India's hottest semiconductor companies. They built India's first high-performance microcontroller, MCU, called Secure IoT, and are building a vision-based chip called VisionSock. MindGrow is incubated at IIT Madras. So Shashwat is joining us from Chennai. And of course, they have also been funded by Tier 1 VCs, Peak 15, Speciale, Mela, and Rocketship. Sash, my question to you as always. I know that enterprises have got access to your chips. When will the rest of us get access to an eval board to play around? And also, welcome to the podcast webinar.
Um, Thank you for the welcome, and the very short answer is very soon. The slightly longer answer is as soon as we deal with a couple of things, and it's fun finding production issues. Fun, not fun, finding production issues just as you want to unveil something to the public. So we're taking a little bit of time to make sure that everything is easy for the public to use, and most importantly, that things are available when people place an order, such that they will actually get the thing that they order. But otherwise, everything is
Nice.
set, and we're just waiting for it to happen.
Nice. Your answer reminds me of this company Aether. I don't know if you follow them. In 2016, they launched their bike, and it was available in the next 6 months for like 4 years. Um, and finally went up on 2018, late 2018.
That's the fun of dealing with
Okay.
hardware, isn't it?
Okay. I take your word for it. I want to introduce to the audience Naveen Goel, founder and CEO at Pinetics. His company makes hardware devices for the medical field for other companies. So you can think of it as a physical hardware shop. Pinetics mostly serves European clients, but they have a tie-up with Mindgrove to make devices based on Mindgrove chips for India. A very exciting tie-up. Naveen is based in Pune. That means that we have three panelists from three different cities. I want to also say that Sai and I are based in Bangalore, but different corners of Bangalore. So maybe we can count it as 4 cities. Welcome, Naveen. Any opening
Thank you.
statements?
Thank you so much. I'm so glad to be here. And I look forward to talking to all of you, sharing what I know. And one thing that is a little different from us is one, A, I'm not funded. B, while I'm an electronics engineer, I've always been on the business side of uh, engineering. So I may be able to give a little more perspective on those sides rather than hardcore embedded systems, which I think Shash and Sai are better equipped doing it.
Cool. Fantastic. We have three lines of questionings or three sets of questions that we'll go through. And then, of course, I understand that there are a lot of questions from the audience, so we'll take that. So first set of questions, Sai, for you, when was the first time you wrote embedded code? What was the situation? What was the ecosystem like? What were jobs like? And in your vantage, how has things changed over the years?
Yeah, my thing was very long journey, right? Like I started my career with Philips when I was writing firmware code for HDMI. You might be knowing these HDMI cables, right? So, and this HDMI connector has a HDMI specification, and I was writing the streaming driver for the HDMI cable altogether. And it was mostly for digital TV, and at that point of time, Philips says DVD recorders. So I was part of that team, right? So yeah, that point of time, I used to roam around with the oscilloscope and measuring your H-sync, V-sync values, right? Purely on the video side, a different era altogether, but a lot of system level knowledge we gathered at that point of time. At that point of time, I remember when I was doing firmware coding in Toshiba, even you cannot write a printf, right? Like when you want to debug something. So we have a memory scratch, and eventually I have to put some signature, like let's take 0x FFFF kind of a thing before starting of the function and at the end of the function. And I have to read that memory again and see all the signatures are matching. Then I know that the control flow has gone through that function, right? So that was a different era altogether, and slowly I think things have been moved a lot. It's not about working only with small MCUs or ECUs. It's about large systems. So for an example, nowadays what is happening, when a new NPU arrives, right, or a new accelerator arrives, you need a lot of software change. Things are going from ARM to RISC-V, right? Or for an example, an automotive OEM is changing the SoC. People are going towards high performance computing in automotive. So things are getting really bulky. Even the hardware systems are getting really bulkier, not at a standalone uh, MCU or NCU level thing. Things are getting very, very complicated. SoCs are coming out. And you might be hearing about new as LPUs, DPUs, beyond your GPUs, right? New TPU architecture. So every time when there is a new silicon is coming out, you need a lot of software work, and that is where I think things are moving, right? Like hardware is fragmented. It needs equal amount of software changes. Any changes in the hardware requires a enormous amount of software change between the hardware and software layer, and that is where fundamentally the firmware engineers and embedded engineers can play a key and instrumental role. And fundamentally, that is where H2 Loop also want to be, right? We are at that translation layer where between the software and hardware, and then I think the opportunity is huge because world is getting towards this heterogeneous compute, and then that should be the ambition of all the lower level engineers, that they should target to this, right? So I think I always thought during that 2000 era when Texas Instrument was there, or at that point of Philips Semiconductor NXP was starting, we were finding a lot of lower level engineers. But off late, when the internet era came, people wants to join internet first companies. Slowly, people focused more on application software development. Uh, that's not bad. That's a good thing. Like India has that opportunity. But off late, what I feel, this is the decade for hardware companies, or the semiconductor era, and I think India has a better chance right now to to fundamentally maximize or capitalize the opportunity, right? So I think there is a huge opportunity for the engineers who are working on the system side. And again, I'll keep on telling that there is a huge demand and supply problem, right? You'll find very specific skill sets people, and that scarcity is there, who understand lower level system optimization, power level optimization, thermal level, voltage level, who understand real memory architecture. It's really difficult to find those people, and I think the time has come to shine again. I think we can revisit completely our stand right now, focus more on system engineering side, and empower the application developer with the right tools so that they can cross the wall and come to the system engineering side, right? And that is where fundamentally Hydron or H2 Loop is really helping. Even though you are an application software engineer, if you want to play around and make some quick demo, and then you can definitely use this tool, this AI powered tool, and can do some real hands-on work. Yeah.
Nice. Those who have been around in Bangalore for a really long time, they remember that there was a time when TI was not there and Infosys was the biggest. Maybe in the early 90s, Infosys was the company to join, and then TI and some companies started. There's a sort of a hardware wave. I don't know how many people they took actually. Um, and
But that good work was done by DRDO and National Aerospace Laboratory, right? They were doing really good work, and I think somehow we missed that train. And right now, again, there's a
it's
huge.
back.
It's
Yeah,
back. Yeah.
it's back in spite of AI, which is the next question because that's the topic of the webinar. So, Naveen, the question to you.
Hmm.
I want to pick up there. Your firm does hardware products now, not 20 years back. So, how much AI are you using? What does the exact workflow look like? Are you using Claude? Are you using Codex, CLI, IDE? I don't know all these things. How are they working? Is their code review still there? What is AI really good at, and where tasks are human only?
Okay. So, see, the whole product development life cycle is extremely complex. Okay, run through many hoops, requires specialized skills across 70, 80 different skill sets. Uh, to answer your question point blank, do we use AI? The answer is yes. Why do we use AI? It helps you jump through some hoops quicker. Uh, it makes product building is also iterative, especially when it comes to hardware, and it helps you reduce the time between iterations. What kind of tools have we used? We have experimented with many. Uh, Claude is something is that we use more. Uh, the interface for embedded people are generally CLI based or a plugin with VS Code. That what we use. But apart from that, we also experiment with Codex and other tools as well. The workflows in terms of product development lifecycle, if you look at it, those steps are pretty much the same. Okay. Uh, AI doesn't do everything for us, or it doesn't work as if that you give it to it and it gets you a final outcome. So it's just like any other tool. As long as you know how to use that tool, you are little more effective, you are a little more quicker, and the output is a little more better in some cases. Now you ask me another questions, in what areas do we use? So if you had to broadly divide a product into sections, then you had that enclosure, which is more like industrial design. Then you have the hardware part where you are working with different kind of components and putting them all together. And then there's a third part is this embedded code that makes it all work together. AI has the largest impact on the coding side as of now. Uh, it is becoming scary good over a period of time. When it comes to real hardware like layouting or placements, component selection, ability to read data sheets, AI is not good yet. So there's a long way to go from now to be able to just tell AI to build me something and it will completely build it for you. I don't think so. We are anywhere there yet. So there is still a huge demand, as I said, and for good embedded engineers. And we should look at AI as a tool in our kitty, than looking at it as a competitor in many ways. I hope I've answered your question in complete.
Yeah, I guess I'm curious. I'll just ask a question to Shashwat because I'm thinking based on what you guys have said. Shashwat, you've taken a chip and SoC to market. Uh, question to you is how much AI was used? Nation wants to know. And and yeah, actually, why don't you answer that? And then I'll sort of ask you a sub question.
So we have a small rule inside Mind Group, which is neither code written by AI agents nor code written by the founders ends up in production. Because one will hallucinate and the other will get distracted, and I will let you figure out which is which. It could be either. But seriously, 2401, the first in the Secure IoT family, was we started designing it in 2023 when the top of the line model was GPT-4o. There was nothing with the capability to do the kind of things that we're talking about now. It was still, it was still at a toy level at that point. And their ability, the model's ability to understand hardware code was not yet, forget embedded code, that's a slightly different scenario, but hardware code was not yet there. But things have changed, obviously, and we do see ways in which it can be used. Now, I have reasons why, we have reasons why we don't let the AIs actually write code which ends up inside chips directly. There are many reasons. But what we do use it for is for exploring a design. We use it for building tooling around the code. So for those who don't know, I'll just take a quick detour into how we build the hardware that we build, right? We write code in a language called Verilog, or its cousins and relatives. And what we do is Verilog code compiles down, instead of compiling down to a binary that you can run on the system, it eventually compiles down to a circuit. And that circuit has to be laid out onto the chip in a format very similar to how you lay out circuit on a PCB. Now, Verilog code, there's not enough of it out in the public for the AI agents to actually learn very well from. But what they can do is we tell it, this is the Verilog code. Now, can you write me a Python model that mimics it? this is the Verilog code. Can you write me a Python model which can quickly run through, change these parameters, run the simulation, figure out what's going on, and let me know which is the best solution. Or I can ask it, given a particular requirement, where are the best, build me a tool that goes and crawls through the logs of this compiler and figures out what is going on. So we use it around. We don't necessarily, we use it a lot for documentation too. So here is the code. Now generate me documentation that the developer can actually use, who has to interact with the system. So all of these things we are using, not in the first chip naturally, but second chip onwards, we are using it in all of these kind of ways. And
Okay.
yeah, I think it's proved to be pretty productive over there.
Okay. That's pretty cool. I think what you're saying is that the main production code may be less or almost nil, but a lot of the other stuff, the testing, the verification, the documentation, etc., a lot, right?
Yeah, and the tooling, especially writing new pieces of tool.
Okay.
There's a lot of manual work in chip design, and you tell it to write a tool which iterates over all of that manual work quickly. Run it overnight. My people can sleep. Yeah.
Okay. Fantastic. So that's where we are. Lots of places have completely, like, the workflow seems completely different from 3 years back when you designed your first chip. I want to just ask Sai, in the context of what these guys said, do you want to introduce us to Hydron and how is it different from, I know Naveen said Claude, so how is it different from Claude? And also a preemptive question, can I use Mindgrove chips on Hydron? Is it already there?
Yeah. So Hydron is basically powered by our context engine, which Loop has built, which fundamentally understand hardware in a better way. That means you can ingest a data sheet, you can ingest a schematic file, and fundamentally to understand your hardware in a better way, right? So you can ingest any doc into Hydron wherever you feel like you can give more information about your hardware, right? So it could be it can take a lot of artifacts, right, from your normal C code to any other docs, right? So all those things are pre-indexed in Hydron, right? So that the agent can retrieve in a very quick time, and the accuracy is also really good. And fundamentally it is also powered by our model, right, which has to look fundamentally built. And we are building different models for different verticals, right, from robotics to UAV or drones, or for semiconductor companies or IoT. So right now it has been pre-indexed with more than 5,000 plus peripherals and SoCs. Is understand the best of the SoCs which is available, like from ST, NXP, I mean to say Qualcomm, Broadcom, all those things right now. And the differentiating factor of Hydron is it is purpose built for embedded and firmware engineering, right? It is not a general purpose model, first of all. And we have a paper called Spark, which is fundamentally our model name. It is there in our website, and we have open sourced all our recipes also, how we have trained that model, which kind of a training data we have used, and all those things. You can have people can go and read through that. So that is one part. It is very purpose built. Number two is the data sheet and hardware informations are pre-indexed. It fundamentally doesn't take much of your token, right? Think about Claude and everything, or GitHub Copilot per se. Every time they do a literally lot of grep, and search it through where exactly the context is available. Here it is an offline context generation part, or indexing part. So the context retrieval is super fast. That is the second part, second advantage I can say. The third and the most important factor here is we are also giving a lot of plugins, right? Like think about you are doing something on UAV side, you are doing a log analysis, or let's take a binary file analysis, right? We are giving very specific plugins for that domain, right? You can build those things in Claude, but again, you will be main thing is again consuming your token, and each token is your currency eventually, right? So first thing is purposefully built for this industry, purely for embedded and firmware engineering part. Second is our context engine, which understand hardware in better way. And third is what I told about the tokenization, reduction of tokens, right? These are the key differentiator of Hydron. And then of late, we are adding a lot of other feature, right? Where we are ensuring that if you are generating for an automotive industry, it has to generate MISRA compliant code. If you are generating for UAV or drone, it should generate DOE 178 compliant code altogether with minimal or zero hallucination, right? That is our motto, right? At a whole, it should intersect, it should understand domain, it should understand hardware, and down the line also our vision is to include physics, right? Because what I understand, end of the day, the AI physics part is also very, very important, where we have to understand your timing, latency, power, energy, voltage, thermal things, memory part, all those things. Your code should be aware, right? And when you are generating AI generate code, it should be aware of all these parameters. So that is our vision, where Hydron will be understanding the physics part, where where most of the code what we want to generate also, we want to make it more deterministic, because end of the day any AI generated code will be hallucinating. As you know, LLMs will hallucinate. Though how do we make it more deterministic? How we can bound it by more physics part? How we can make it more verifiable on hardware, right? Because our company name is hardware and human in the loop. So the whole objective is how will you ensure that the code, which is AI generated code, will run directly on the hardware. It should be aware of the target hardware. It should be aware of the compilation environment or the execution environment. So these are very hard problem, right? And
Yeah.
you can do a
Yeah.
lot of things with Claude and GitHub Copilot, but they will not take the onus of running it on the
Sure.
hardware and actually working, right? So these are the
Sure.
top of the points. Yeah. Yeah.
Thanks, Sai. Before I ask you the next set of questions, it's about product and career planning. So, but before that, I want to just take a moment to acknowledge our audience. Thank you for joining us today. Really grateful. We had about 500 registrations, so there's obviously a lot of uh, questions that are bubbling in everybody's mind. And to our surprise, it's a half and half split between the folks working at companies like Bosch, CDAC, Analog Devices, Honeywell, Qualcomm, Infineon, which was a surprise to us. And also the other half being students who have a lot of questions about how they should plan their careers. And maybe the folks working at the companies also have that question. Uh, right. So want to acknowledge that. Thank you for joining us today. I, there's a small housekeeping point here. The questions you have, please put them in the Q&A box. If you put them in the chat box, we are not able to keep track. If you put it in the Q&A box, the panelists get to see them. It's easier to answer. Also want to acknowledge my colleague Vamsi, who's here. Sorry, my friend Vamsi, who's here. He also leads embedded engineering team based out of Chennai. They make medical devices for eye doctors. So some of the questions he'll be answering as you type them, but only if you answer them in the Q&A box and not if you ask them in the chat box. Thank you so much. Let's get on. I feel like product development is changing very fast. Naveen, if you can give us an idea of how this impacts product development, how has it changed? How were you developing products earlier? And also my favorite question now is if I use tools like Hydron and Claude and all these other things, can I build a smartwatch in one day? That's my
Okay.
goal.
Okay. So allow me a couple of minutes of monologue. Okay. So when you said that a lot of people are here and they are here for, some are scared, some are curious, and some really want to know how the world will look like, especially when it comes to embedded systems using AI. So AI is here to stay. Okay. And I have seen its capabilities change over the last few years, and it is becoming good at a lot of stuff. What Sai did say and how it is H2 loop is a little bit different is because most AIs are unable to read data sheets properly and they do a ton of mistakes. So we do use AI selectively. As I said earlier, uh, see the number of steps don't go away. You have to do all of those steps. Compliance is a huge part of it. And when it comes to medical electronics, you need to jump through those hoops of if it's a US, then you have to use US FDA. If it's EU, then EU MDR. Indian CDSCO is also becoming quite strict. And then there are more other countries who are also coming up with their form of regulation. So hardware, building a product that works on a tabletop is one thing, but building a production ready product that satisfies the regulatory need and goes to the market is different. Earlier, a medical product would take, before AI maybe, would take maybe between, depending on the complexity, between 2 to 4 years. So that is the kind of patience that anyone had to keep to see a product from ideation to market. 2 to 4 years was essentially what you could see. I did say that building a product is an iterative process. Rare that you will get the hardware right in the first go or the PMI EMC compliance right in the first go. So there is generally at least 1 or 2 iterations depending on the complexity again. With AI, we are able to reduce the time between iterations or the time that you take in some steps, especially on the embedded coding side. Say you had to tune a LDC motor. It would take maybe a month or so to do it earlier. Now you could do it maybe in half the time or even lesser. So those steps don't go away, as I said, but you could reduce the time between them. Then, of course, code reviews and all of those standard stuff, AI does better. Uh, does the speed increase? Yes, the speed does increase over compliance, and all of it is out of our control. It is generally the regulatory body, so they will take whatever time they take. So that time doesn't go away. Uh, but your engineers are able to do more in that time. And it is my opinion that the grunt work, the boring stuff, the run of the mill stuff will be taken care of AI over a period of time. And humans would be able to do more complex stuff. There is still so much to be done. We have not even scratched the surface when it comes to hardware products and the capabilities that they will do with applications across medical, defense, automation, and mining, all of that sort. So well, we will start seeing more products coming out at a much faster pace and again compliant product. So in just AI is here to stay. Use it as a tool. Uh, Look at so to give you an example of if you were a pianist in an orchestra, okay, now the AI can maybe, if I have to use that analogy, AI will play the piano a little better. Maybe you do orchestration better. So become the master of AI. Use AI to orchestrate and do the harmony, the symphony, and do more stuff with it. So that is something that I want to leave you with. And apart from asked me a question that can I build a smartwatch in a day? Tabletop version, yes. You will do something on the table that will work. But can I wear it at home? No. It's still There's still a lot of work to be done. to take a product to market. It's not easy. I'm telling you, hardware is not
Sure.
easy. The word hardware has hard in it. So
Sure.
yeah.
Sure.
So yeah,
Sure. So you're saying more products will come out in almost every segment, right?
100%. And the products that you haven't even thought about yet. Again, there are
Yeah.
so many difficult things that humans do yet because there is no product for it. You don't get people,
Yeah.
for example, in India, manufacturing, you want to increase manufacturing output. There are not enough blue collar people wanting to do labor work. Then you will not need robots to do that. So then what will humans do? Humans will start asking better questions. They'll be more curious. With curiosity, more products will come out. So the ability
Oh,
to ask questions will is something that I think will drive more products to.
I hear you. I hear you. Shashwat, your company, of course, is betting on the fact that there'll be a lot more products, embedded engineering. And I mean, it's almost like if it doesn't explode, then who's going to use your chips, right? So, do you have a strong opinion on this?
On whether whether it's going to explode, I
Yeah, and
think it needs
how
to
should
explode. I think it
okay.
needs to explode, and we are the kind of country where something needs to happen. Eventually, it will. It may happen in the most oddball, quirky, roundabout way, but it will happen. And I mean, just look at the amount of. So the thing is, whether you're talking about hardware to do something special or you're talking about AI, you're really at the end of the day talking about trying to remove some of the grunt work that we do. You know, Sai and I started our engineering. We did some of the earlier engineering stuff. Sai can tell you a lot more about sitting and trying to write assembly code to break your head over something very simple. And we don't do that anymore. We have, I mean, I was giving a talk a few days ago in a different event where I said, I grew up at a time when you probably encountered electronic devices maybe once every 2 or 3 days. Electrical, yes, every minute of the day, but we're not that old. But electronic devices maybe every few days, right? And today you can barely take 10 steps, blink, and you open your eyes on a different electronic device. So you're talking about things that are going to that are important in reducing the grunt work, reducing the friction in our lives. And I think that's just going to keep happening. You know, something as simple as the dongles that you use to sign documents. You don't think about it, but that's an electronic device. It has a chip inside. It has security requirements. It has a layout. It went through an entire product development life cycle. So those are things I think they have to explode. And like Naveen said, there are
But Shashwat, talk me through this dichotomy. You are saying that number of products will explode.
yeah.
At the same time, it feels like engineers are writing less code. So there's probably fewer engineers required because AI is doing a lot of the work.
So
So
I've been thinking about this, right? And it's not that engineers are writing less code. They're writing less meaningless code. They're writing less boilerplate. And that has always been the dream. That has always been the goal of every development framework that I have seen, front end, back end, embedded. I mean, that was the whole promise of Arduino. Serious embedded engineers hate Arduino because they say that it's like opening up with what is this? This is something that barely passes the test of being embedded. But it is something where you start off your design, you start building out what you want. I mean, like you build a sketch and then you can start iterating on it and maybe go down a layer, go down a layer, go down a layer. So a lot of that boilerplate just, again, going back, when I started doing embedded engineering, you had these programmers. So you had to, your chip sits on a socket on the board. You take it out, put it in a programmer, program it, put it back here. You could not do something as simple as put a breakpoint on the chip, on the code, and see what is happening. And so we wrote an entire amount of boilerplate junk, basically, to observe what the chip was doing. You don't need to do that when you have an Arduino which is plugged in through USB and you're observing the code as it runs. And I've used that many times in a professional context, just for that ability.
Right.
And so what you're looking at is something very similar. You don't need to break your head over 20 different data sheets of devices trying to figure out which one to use. And am I hitting this thing because, those debugging sessions can go on for days. And I mean sleepless days. Now you have something, you have a genie which you're telling it, go figure this out. At least go over the logs and figure it out. Or write me a little bit of extra code to log when this happens. You're cutting your days down to hours. And what you're really doing there is improving productivity. You're not actually replacing engineers. Because that intelligence of architecture and that intelligence of stitching a system together is what the engineer really does, not writing code. It's never really been about the code.
So I would just want to butt in here and add something. And we do product development day in, day out. Doing board bring up is the most painful thing that you could do in a product development. And sometimes for the life of it will not work. And you don't know what's wrong. Hardware people will point at firmware, firmware will point at hardware. You know what? Sometimes this genie that Shas is talking about, even it just points you in the right direction, it may save you days of figuring out where the problem is. And sometimes it could be just a small thing somewhere in some corner of the board. But point being is, it does help. And to answer that question about requiring less engineers, trust me, you'll require more engineers who ask questions. So
Yeah.
there is a set of engineers who would do grunt work and they're happy doing it. For them, it's a pro. But there is a set of engineers who don't want to do grunt work, but they want to do innovative work, which AI cannot do. And it starts with the ability to ask good quality questions or being just curious enough.
Great. Fantastic. So, Sai, I'm going to ask you a follow-up question here. And I'm seeing some of the questions that are coming in the Q&A box are also very similar. If I'm in college now, I have to plan my internships, I have to plan my projects, right? It's not going to be the same that was 10 years back or 20 years back. And even if I'm in like my job, but early career, like 1 or 2 years down, I have to take some action. How do I adjust to this new reality? Like, what are the projects I should do? What are the courses I should pick up? What are the new skills? Sorry, I'm lobbing a tough question on you, but
No. I think we are in a different time altogether, right? So suddenly people are reading about physics these days. People are reading about mathematics suddenly, right? They think that computer science is all sorted through AI now. But I think uh, when I was writing code 20 years before, even I write code now also, right? The fundamentals remain same, right? Like if you go to a Google interview now also, they ask for time complexity, space complexity, how optimally you can write your code, right? So the whole part is how closely you understand your hardware. You should understand more about system, how memory works, right? When you declare a normal array in C, what exactly it happens, right? Like how it goes through L1, L2, L3 cache up to your DRAM, what actually happens at a capacitor level, right? You should think at that level, right? You declare a variable. Everyone would have been written a normal program int x equal to 5, right? What exactly it happens internally? So that is all about system thinking, and I think that is what I should tell to people or a student. They should think more about systems, right? And that knowledge will be there forever. And even though you are building a AI product, you are using AI, that will never go, right? And that is where you can build systems. Number two, yeah, a lot of things are happening. People are thinking about physical AI, right? You can pick up any project where you can take a model, optimize it for a specific hardware. Because I see robotics, physical AI is getting into the next stage, right? Like I know almost 15 companies who have raised more than 500 million, right? On the
In physical AI.
in physical AI side, right? It's a huge thing. Yeah. Uh, End of the day, machines has to be programmed, and it has to be programmed through right software. A lot of models are getting built. People are deploying vision models, speech model. They have to be like, you have to understand system and you have to understand AI. If you are the bridge, if you understand both AI as well as firmware engineering and system engineering, that's a different level of skill. And very few people have that skill who understand how AI model works, how inferencing works. At the same time, they have a system level knowledge. They understand how embedded engineering work, how firmware engineering work. If you can join both the world, then that's a different kind of a skill. And very few people can do that at this point of time. And that is what mostly I can suggest students should be focusing. Understand system, understand AI, and figure it out a way how do you build a project around that, right? That is one part. The other part is yeah, do some internship with some actual hardware product where you can demonstrate how AI can use, even though it is not about writing code, even though it is validation and verification, that is also important, right? As Naveen and Saswat told, a lot of things will go towards verification, validation, generating test cases, log analysis, right? It's not about writing code. To be very frank, I'm working with a lot of customer who only wants to port code from one language to another language, or code modernization, refactoring the code, existing code refactor, translate the code, or port from one hardware to another hardware platform. So it's not about writing code. It's the same code, but how do you port it from one specific architecture to another architecture, right? So that those work will go. There will be a lot of work on that side, right? People wants to modernize legacy systems, right? Because new hardwares have come, new powerful hardware, but you have to do a retrofit with your software because software is old. You, if you want to maximally utilize your new age hardware, the software has to be refactored, right? Obviously, you
Right.
have to
Right.
go from monolithic to service oriented architecture code. So a lot of refactoring what we are seeing, because as the hardware is getting fragmented, there is a huge work on the software side to maximally utilize the hardware, right? So that
Right.
is where the world is heading to, and that is where mostly the new age guys, the students, if they're just now coming out of college, they should focus on these areas. Yeah.
Yeah, you and also Naveen added earlier in the conversation that context awareness of what the customer needs and what are what are we actually solving, that is also going to be a really big skill for electronics engineers. Fantastic. I have asked Vamsi to post some of the questions in our chat box. Um, so Shashwat, do you want to take the first one? I feel like this will be something that you can answer, but I have no idea what the question is. Sorry, guys. I'm not an embedded engineer, so sometimes I just, in our times, we used to call it OHT, overhead transmission. Um, that's what's
Just
happening
put
for me.
it
So,
here,
what
yeah.
hardware?
Someone will answer here.
Yes, yes. What hardware skills should an embedded engineer learn to work with today? Dash, GPU, NPU, DSP, FPGA, AI accelerations? Question mark. Roadmap? Question mark.
Uh, you know, I have this. If you're just starting out, right, and you're trying to build up your muscle, I have this analogy which I love to use about when the Mongols wanted to train horse archers. They had two options. They could either take archers and train them how to ride a horse, or you could take good horsemen, guys who grew up on the saddle, and teach them how to shoot an arrow. It turns out that the second one is easier to do than the first one. So in our context, an embedded engineer really needs to learn hardware, like learn the physics of how electronics works, build devices, uh, build boards, burn a few boards, smell the smoke of cooking chips, and from there you start building up, writing low-level code, interacting with different kinds of hardware. Those are the muscles. Those are the basic muscles that you need to build. That's your core strength. After that, when you look at it, do I want to implement it on an FPGA? Actually, FPGA is a skill. In a sense, it is designing hardware. But before that, actually playing with the hardware and trying to understand it is, I think that's the core skill that you need before you can go after AI accelerators or GPUs or NPUs or anything. If you use it to solve a problem, so for example, there's not a embedded side problem that I'm talking about, but at one point in my career, I had to write a ray tracer, and we decided to use it to write it on a GPU. So there we were using this is old GPUs where the G actually stood for graphics and not whatever it does today. So we actually sat and learned how to use the GPU for that narrow purpose. And that kind of a thing is where you actually, but the ray tracing skill itself came from me. And that was built into the way that I learned how to engage with the field that I was working in. And that, I think, is the key that you should think of. It's not a particular technology that you should be looking at. It's those basic muscles of learning how to play with hardware, deal with hardware, lose the fear of hardware.
Yeah, I want to add something here, and this is from one guy who wants to build products and building product. Please learn to use a solder gun or a solder gun. Okay, please, you may know engineering, but if you have not soldered anything or burned something, then you cannot call yourself an engineer. And one thing, there is no replacement for fundamentals. Please, you should know your basics electronics, differential ground, eddy currents. AI will not do all of that stuff. And when Shah
No, I
says you should
can't.
know your products, go understand what T states are and all of that stuff. This is something that is irreplaceable.
I feel like there should be a way to build a physical AI robot saying, I need to solder these things. Please do it for me.
Not happening anytime
They
soon,
exist.
man.
See, they exist. They exist for doing like 10,000 boards. But then they
Right.
like staring at a board and you go, oh man, that's the thing that has gone wrong. And then you bring out a piece of wire, solder it there, and
Yeah.
that's a skill.
I have an
Okay.
engineer here who can, through the eye, can solder a 50-pin chip. I will go blind, man, and he does that. And I sometimes someone say I need a wire out just to debug, or I want to do something. I just need to understand something there. So he does that. He's always
Nice.
with the solder gun. So do those
The
stuff.
human Claude.
You need to.
Yeah.
Sai, there's a question for you. Let me just, sorry, I lost the question. In case that I want to create a product based on an RTOS chip and sensor on a custom hardware board for a new product design, how does Hydron handle the new custom hardware schematic and new chip at the core of the project? Can the end user train the model, or what would be needed to be done by Hydron engineers?
Okay, it's not about training the model and everything. Fundamentally, I think H2Loop can help you in understanding the SOC or the MCU datasheet, right? And you have to feed a lot of information to Hydron, like your reference board documentation and other things. Like for an example, if you have already built any SDK or a BSP, you can provide that, and Hydron will derive the context You can also give any kind of a constraint, like what is your power management requirement and all those things. And based on that, Hydron will start building it. So it helps you in bringing up the board, implement any kind of a I2C or SPI driver, any kind of a reading of sensor data, blah blah blah. And you can analyze and reiterate, because it's a agentic framework altogether. There will be a swarm of agents who will be start working and building it for you. And the more, again, I'm just keep on reiterating, the more information you provide, what you're trying to build, the better output you can get it. But again, there are three parts. One is the harness part, which already we have built. There's a context engine, which will help you in deriving the right context, powered by our model. So it will be more like a full-fledged multi-agentic framework, which will get your work done. It's like almost 10, 15 co-workers who will be working on each task. We orchestrate that task also, and eventually it will be powered by our model, so which understand how to write a very specific embedded and firmware code, and with minimal time, minimal token, with minimal involvement of the human, you can get your job done. Yeah.
I feel like, Sai, we should plug now that your team gives demos and somebody should book a demo with you. And maybe, Shubha, if you have the demo link, you can paste it and they can book a demo. Shashwat, question for you. It's my favorite question of everyone. Any rough time frame of the Mangrove eval board? Sorry.
Oh man, I did any of every one of my fellow panelists here is asking me the same question. So the only answer I can give you right now is unfortunately supply chain, and we will have it in the shortest possible amount of time available. I don't want to put a link up for people to order it and then not actually have it on hand to sell it. The thing is, I have the chips, and we're dealing with some last minute issues with the boards. Want to make it available at a reasonable price point and reasonable lead time. So working
Sure.
on those kinks before we actually go out and say, guys, you can order.
Okay, you heard that, guys. Let's not ask him again.
One more
It's
thing is, I'm also in line, by the way. For people who don't know, we are coming up with a medical product based on a Mindgrove chip very soon. And it will
nice.
be in hospitals, by the way.
Nice, damn cool. Naveen, I want to ask you this question. This is like
Yeah.
fairly, like I feel like people have asked me in person also.
Mhm.
When you look as a young person,
Mhm.
whether you're looking at internships or you're looking at job opportunities,
Mhm.
of course, there are lots of AI internships,
Mhm.
and entry-level job opportunities, but embedded system opportunities are much fewer. So how does one go about cracking these?
I'm not so sure if that's true anymore. Very honestly,
Okay,
see, if you look at embedded, you should look at both aspects. One is the hardware. So once you have become an electronics engineer, you generally have two broad branches. One is, do you want to be on the hardware side where you're doing schematics, PCB layouting, and working with chips and all of them. And then there's the other part of it, which is essentially doing the whole coding part, and that is also looking at operating systems, bare metal, and all of that stuff. uh, these are generally two separate sets, but they overlap. A software guy or an embedded software guy should be able to still go in the lab and solder and work with the oscilloscopes and everything. And the hardware guy should still know a little bit of code to help. Okay, this is what it's working, this is not how it's working. To answer your question, are there less jobs and opportunities? I don't believe so. As a matter of fact, more and more companies are coming forward for more and more hardware products, defense, space. There's enough and more work. If you uh, look, forget the AI internship part. Just look at internship part where you will get to work in a lab. The only question, if I would be an engineer coming out today, my only question is, will I be able to use the lab? That's it. If the answer is yes, I would run to that place and experiment as much as possible. Enough and more
Yeah.
tools, enough and more books are available to brush up fundamentals and everything. Do I have access to a lab is something that is very fundamental.
Sure. So you're saying that it's growing, there are more and
Oh,
more opportunities available,
yeah,
and
we
look
always
for
have open
labs.
positions like us. I'm sure Shashwat can say the same thing. Sai will say the same thing from an embedded side. There are tons and tons of jobs available. The question is, I don't want people who do the grunt work. I want people who are able to think. I give you a problem statement, go figure it out.
Right. Thanks for that. We asked for 1 hour from your time, so I want to just be cognizant that 1 hour is over. I want to ask you a few more questions, and maybe
Sure.
after that we can wind down. Sai, this question is for you. Um, Somebody's commented saying that AI adoption in legacy automotive systems is quite low. And my question, I want to rephrase that. I want to ask you a question. You have wide exposure across industries because you're building a tool for all kinds of industries, right? So where has AI adoption been really fast, and where are you seeing really heavy momentum?
No, actually, automotive is growing, right? I mean to say, see, wherever there is something where the intelligence is coming to the software, right? Like software-defined vehicle. People are talking about software-defined defense. Previously, in networking side, software-defined network was there, where they were adding a data plane layer, control layer. Fundamentally, the hardware intelligence was coming to the software side, right? And these are the industries where there is a lot of momentum, right? Like right now in a car, for an example, 100 million lines of code, it's like a moving data center, right? You have multiple HPC zone, you have autonomous driving, ADAS, OTA feature, your infotainment is a different thing, a lot of software, right? I think a lot of software is getting written, a lot of software is getting refactored, a lot of porting is happening. Nvidia kind of people are getting into automotive, right? They are giving the chip and all those things. So I think there is real traction is coming from automotive side, as well as a lot of things are happening on drone side and robotics. Physical AI is a real thing, right? People are like think about in India itself. I think more than 700 startups who all are working on drone side or robotic side. Like it's just huge, right? That the number is huge. So that is where lot of action right now. At the same time, I'll not deny the fact that defense, the pull is also huge, lot of tailwind from
Which
defense, right? Lot of new hardware are coming, they are making everything AI ready, right? Even
I heard
old systems is getting AI ready, kind of thing.
I heard from someone that there are 150 plus drone companies in India in the last 2 3 years. It's crazy.
Yeah, it is actually right. So
and
that is
there
what
will be more. There will be more.
it will be more. So that is where they're telling this is the decade of deep tech startup, right? When I'm telling about deep tech startup, it's all about hardware for startup, right? So the pull is coming from everywhere. Uh, but again, even think about avionics companies, right? They are also started adopting AI in their workflow. Yeah, they are starting at a not at a code level, but how do you can in compliance altogether, right? How do we can quickly make DOE 178 compliant, right? A lot of process related optimizations are happening through AI. So the pull is everywhere. I mean to say, uh, to start like drones, robotics, automotive, defense. That is where the real tailwind is there right now. These
Yeah.
are the sectors, yeah.
Just to add to what Sai just said, you think about any automobile, right? You're talking about tons of chips, tons of processors, which each are doing their own thing and each are running their own code.
Yeah.
There is a movement for using AI and other tools to even understand what is going on in that mess of code and wires. So you may not see somebody vibe coding transmission ECU, but you will. I mean, you walk into any automotive company, and besides which, last few years we've been tracking automotive chips coming out. I don't think I have seen a device come out in the last few years which doesn't have an NPU on it.
Yep.
Now, forget about infotainment, ADAS is one side. Things like the brake controller is now having an NPU because it's actually running an algorithm to figure out the ABS. It's running a model. So I don't think you can dismiss automotive as saying automotive has this reputation for being slow, but they can be very fast when they want to.
Yeah, from China.
Are you saying that under the hood there's a lot of action made?
There's a lot of action. I think there is a lot of action for somebody who's interested in all of these, the intersection of all of these things. I think there's a lot of action.
Okay. Sai, I cut you. Were you saying something?
No, I was telling there is a lot of pull from China, right? Like,
Yeah.
The kind of software development is happening, the kind of rollout of cars is happening, the speed at which the rollout is happening, it's amazing, right?
It's
And
incredible.
yeah, and that
Okay.
is where all the innovations is also happening, and everyone is getting excited. How do
Yeah.
we roll out our hardware or cars faster?
Okay. I hear you. The speed at which Chinese car companies are pushing out products, it's putting pressure on everyone. Everyone
Yeah.
has to respond.
Yeah.
Naveen, question for you. Sometimes it's difficult to remember fundamentals. Being an embedded engineer, what are the fundamentals to revise?
Okay.
If I have 3 or 4 years of experience, go for
Fantastic
it.
question. Yeah, fantastic question. And to all the engineers here, I would want to tell you that do a few things. One is learn motors, okay? PLDCs and all of it, brush up everything. Feedback control systems, okay? Then your electromagnetic engineering, how antennas work and all of that stuff. Then you should brush up on of course, microcontrollers, the basics of it and how it works. Uh, then I would really want you to, again, I'm bringing that topic again. Please learn to solder. Please learn to work with devices and see what these are. And mathematics is important. For example, in signal processing, you'll require Fourier transform and all those filters that you need to work with. Some on the hardware side, some on the firmware side. So you need to have decent understanding of the models like Fourier transform and all of them. So you know what? While engineering is 4 years, okay, but even if you have done it, you could actually brush up on a lot of stuff within a couple of months. So I would recommend to go back to these stuffs, and especially the ones that you thought was very difficult. Like for me, EME was very difficult. Electromagnetic engineering. Just go back to those stuff. Important stuff.
I was just saying this, I'm not an electronic engineer, but in marketing, sometimes I feel like I've done something 10 years back. Often find myself going to Claude and saying, there's this thing that I want to know. This is what I remember. Can you please help me brush up?
Yeah.
Otherwise,
Yeah.
I'm going to say something stupid to a client.
No. But you use AI to learn, refresh
Yeah,
your
that's
fundamentals.
actually that's something that I've done myself, and I think you and I did that once, Amrit, sitting together. Was something that we had seen many decades ago, and then we were sitting live with I think Gemini at that time, and we were asking it.
That's right. That's right. That was something I'd heard in 2008, and I didn't remember like 90% of it. And we were like, please help me with this. Okay. That was great. Thank you so much, folks. I want to tell you how we do post webinars. So what we do is we run the Q&A transcript and the webinar transcript through Claude and say, please change this into a Q&A format so that I can send a Q&A to everyone. And this time, since you guys have said it many times, we will do a human in the loop. After Claude generates said, one of us, or maybe Vamsi can help us, we check that all the answers are right. And to all the participants who have come, we will send them the recording link and the questions and the answers that were discussed in the Q&A box and during the conversation. That sounds good. Folks, any parting thoughts before we close?
Yeah, probably I'll go first. Yeah, as everyone is telling, AI will be there, right? And there is no doubt we can get rid of AI. But at the same time, I don't see you will be replacing humans. So fundamentally, hardware will be there, human will be there, AI will be there, and I'll not try to market myself. H2 Loop also will be there because we are hardware and human in the loop with AI, right? So that is my thought, and this decade is all about all deep tech and hardware companies will shine for sure. Yeah.
Okay, I guess I can go next. In a world where everybody is talking about AI and models and everything, I think the engineer who will truly shine is the one who can keep the architecture in their head and actually think through problem solving and design, and how the user is going to interact with it, how different people along the chain are going to interact with the design that you're building. And those are skills to develop. Coding or working your way through some of the like we kept saying, the grunt work is not necessarily, it was an easy way to get started. It's still an easy way to get started, but I feel like working on that, working on the ability to think a little bit on the meta level is going to be critical. So I see a lot of scope for really good engineers to shine.
Okay, so I will go last. And one, AI, if you are scared of AI, I understand. Don't be. Okay. Look at it as a partner and not someone who is going to replace you. Your mindset shift is very, very important. Okay. Where humans will always be needed. Humans will be needed to think, to be creative, to ask very pertinent questions. Okay. And never ever forget the fundamentals. If you do those 2-3 things, I think you are sorted.
Yeah.
Nice. Cool. Good conversation. Thank you so much, gentlemen.
Thank you.
Have a good evening, everyone. We are going to send everyone a follow-up email. We also have a WhatsApp community, so we'll send you the links. Yes, see you on the other side.
Thank
Bye.
you. Thank
Thank you.
you. Bye.
Thank you,
Again.
Saswat, Naveen. Bye.
Bye. Bye. Bye.